Okay, the logic errors are the tricky ones. These ones, what makes them tricky, I mean, the type errors could be kind of logic errors as well, connected to that. But the logic errors are tricky because it's not a syntax error, and when you hit run, everything seems to be working just fine, but it's not right. That's hopefully your cert tests are helping you know when something's failed or not. Now, I do want to take a moment to make sure I'm emphasizing, don't use those assert tests as a crutch. If whenever I give you a cert test and you're using them, great, but if you're in lab and you work on a thing and you get it working and you don't test it, you've basically, like if I asked you to turn in the labs, for example, and I didn't see a cert test with everything, I wouldn't even mark your code. It's not done. So if you've been skipping the tests, you've been not finishing your work. It's simple. These assert tests, they're not guaranteed to ensure that your code is correct, but it's going to catch a lot of issues. And you better start writing these tests too, because you got to know and learn how to write these tests. Now, we're going to learn a lot more about how to write these tests a lot better very soon, because assert tests are very limited in what they can help you with, but they're great. They're quick and dirty and great. And the tests are there to help you find logic errors. You know, you hit run, the code ran, it didn't crash, but it's not doing what it was supposed to do. I think we talked about this last time too. The tricky part here is, what is the root cause of the bug? You've got your problem, you thought of your solution to the problem, and then you have your implementation of your solution. Is the issue between what you want to do and how you implemented it? Was there an issue with your implementation? Or was there an issue with your original idea of how to solve it? Is the logic error here, or is the logic error here? And that's tricky to distill. There's a couple of strategies for finding these bugs, these logic errors. First and foremost, it's possible that you miss these entirely. And if you do, well, God help you, right? You got to check these. You got to make sure your code's correct. It's not about writing the code. It's about writing correct code that's good. So here's hoping you tested it and whatnot, and you caught any issues. You're running it. It's working, but it's giving you the wrong answer. Okay, why? Well, often it's coming down to, you know, is it the flow of your algorithm that has an issue? Is it the values of some variables that have some issues? I don't know. So what you do is you throw prints everywhere. What you do is you look at your code and you say, okay, I think the issue is around here in my code. And we were talking about this on Friday, right? Yeah, because we talked about this example, right? Well, you look at your code and you say, there's something wrong here. I think, though, based on what the code should be doing, the value of that variable at this point in time should be 7. I don't know. So let's check it. Let's put a print in there, print out the value of that variable, and hit run. Was it 7? Was it what you expected it to be? If it was, okay, good. Problem's probably somewhere else. So you throw another print somewhere else. Okay, at this point in the code, that variable should have the value 42. Again, arbitrary values. So you print it out, and it's not 42, it's negative 40. All right, well, you're starting to narrow in on where the issue is. Who here's been using this strategy already? Throwing prints into your code. If not, do it. You're missing out the easiest low-effort trick to debugging, is print everything out. If you go look at my assignments from my undergrad, you'll see it full of commented out prints, because computer scientists are too scared to delete a line of code. They just comment them out. And it's not just about the value of variables. It might be, well, okay, because that condition's true, this if statement will run. Did it? Put a print inside that if and hit run. Did you see something get printed out? You know, put a print inside that if statement and have it say, like, the if statement ran. When you hit run, did you see it? Yes? Okay, it ran. If you don't see it and you thought it did, we got an issue. Did that loop run the correct number of times? Okay, have it print something out and count. Did it run the right number of times? There's a lot you could do. Prints are easy, low effort, but pretty effective at letting you know what the hell's going on inside your code because you get to see it. Pencil and paper. Now, this one here, it doesn't really need to be pencil and paper. You could do it in like a notepad on your computer, but the point is to get yourself out of your code. Because you're coding, and one of the biggest issues programmers have is they'll make an assumption about a line of code. Or maybe they'll make an assumption about a few lines of code. The number of times, and I think students think I'm trying to be like demeaning, but I'm not. When I'm in lab and I ask, okay, explain to me what your, and you say to me, there's something wrong with my function. And I say, okay, well, explain to me line by line what your code's doing. First and foremost, if you get annoyed at me with that question, just leave. Because clearly you have no interest in learning this stuff. I'm not saying that to demean you. I'm saying that to tell me what this code is doing. So, if at any point in time you're like, okay, well, and students tend to get annoyed with that because they'll be like, well, no, just tell me what's wrong with it. No, I'm not going to do that. That's your job. The whole point of this stuff is to implement it. It's not about getting the right answer. It's about implementing it correctly. Obviously, at the end of the day, if you did everything correct, you get the right answer. But that's not the point of doing these things. It doesn't make me happy when your code outputs 77 when it's supposed to. What makes me happy is that you implemented that code to have it output the right answer. That's the good thing. That's the important thing here. So I'm not going to give you the answer. I have no interest in doing that, and neither should you. When I want you to explain line by line, it's because one of the biggest sins programmers make is you assume something about your code. So I'll say explain line by line, and they'll say like, okay, well the top here, that just sets up some variables. Stop it. No. What does the first line say? And it's crazy how many times back and forth it'll take before someone actually does what I say. And I'm not saying it because I think you're incapable of doing more than one line of code at a time. I'm saying it because I know you're incapable of doing it more than one line of code at a time because your code's wrong and you're making assumptions, which is a huge mistake. That's a big issue. It's not that you're never going to be correct. No, it's that stop making assumptions about your code. Because, and now be honest, how many times have you been debugging a function and thought to yourself, how many times have you spent a lot of time debugging your function only to have been chasing an issue that you thought was over here to discover that, actually, no, this was all correct. It was just that I assumed those two lines of code worked one way and they did something else. Has that happened to you? Of course it has. Stop making assumptions about your code, line by line. And that's the big thing here. When I say, get out of your code, pencil and paper, it slows you down. It makes you very deliberate about every line of code. What you do is you follow along line by line with pencil and paper to keep track of every value of everything that's happening inside your function as you go. Make no assumptions. And as soon as you say, okay, well that if statement, that's just going to check. Nope, no. What does the Boolean condition say? What are all those values? What did it evaluate to? Was it true? Okay, then you know you went inside. Slow it down. If you think you could break it, if you could say, well, this is how I break it down into steps, break it down into even more steps on how you're trying to eliminate all assumptions, okay? Don't make those assumptions because, as we just saw, that's going to bite you. It always does. It might sound tedious. It might sound, well, that's going to take a while. That's the point. In fact, if it takes you 4 or 5 minutes to do it, but it would have taken you half an hour to debug it without doing it, you're better off taking those 5 minutes. Just slow it down. Take your time. Now, in addition to everything I'm saying here, I want to make sure the best thing you could do for debugging is don't have bugs in the first place. And I know I said this Friday. Just don't have bugs in the first place, which I realize is a ridiculous statement to make. But there's a lot you can do when writing your code to eliminate those bugs along the way, such that when you got your function in the end, the number of bugs you have will hopefully be less or none if you've been doing it well along the way. What I mean is, you write 1 or 2 lines of code of your function as you're writing it, and you run it, make sure it does what you expect. Add a line or 2 more, run it again, does it do what you expect? A line or 2 more, and so on. Slowly, write a little bit, test often. If you do that, you're going to eliminate a lot of bugs before you get to the end. And those bugs that you find along the way are a hell of a lot easier to stamp out than the ones that you're going to find when you hit run on your 25-line function, and it's not doing what you expect it to do. Yeah, good luck. And if you think, well, just because I'm not experienced enough to debug a 25-line function, no. You come in my office hours and you give me a 25-line function, you're like, help me debug this. I go like, I don't want to. It's a lot of work. That's not easy for anybody. Don't expect it to be easy for you. You're not good at debugging a 25-line function because you're bad at it. You're bad at it because everyone's bad at it. I don't care if you've been a programmer for 30 years. That's hard to do. So it's not your inexperience that's making it difficult. It's the nature of the beast that's difficult. This is all to really emphasize, look, we made it this far in the semester, and everyone in here knows how comfortable they are with everything happening in the course. If you're really happy with everything, good. If you're a little concerned, well, you know, take care of it. You know what to do. There's a lot of resources available for you to catch up. But either way, if you've made it this far and you're happy with where you are, your limitations now, some of it is, okay, you're inexperienced, you're still learning, fine. But some of it is, like, you've learned enough that some of the difficulty now that you're encountering is just the difficulty of programming, the challenges of programming. Not because you're new, not because you're green, but because it's just, these are the challenges of programming. I wrote my function, it didn't work, I must suck. No, that's programming. I spent 2 hours debugging my function. That's programming. Not because you're new, but because that's programming. If you've been doing this for 2 years, the difference between you who's been doing it for a couple months and someone who's been doing it for 20 years is they might be a little bit easier to expect certain bugs. They might be able to recognize certain styles of bugs because they've encountered them before, but that's it. It's not just because they're better than you. No. And then delta debugging. This kind of goes back to what I was saying before. Write a few lines. Let's say I'm telling you, write your code in the first place such that you're eliminating these bugs along the way. And you're like, well, too late. I wrote my function, it's not working, I need help. So I'm going to say, okay, delete it all. And start again, and write 1 or 2 lines of code. And if you're a decent programmer, you're going to be really scared of deleting any line of code, so you're just going to comment those lines out, fine. You comment them out. Then you uncomment them out 1 line at a time, and you hit run. Did it work? Did it work as it should have? Add another line. Did it still do what you expect? Add another line. Does it do what you expect? Yeah. This is like going back to the beginning. And you make these small little incremental changes and make sure it works along the way, and hopefully you'll discover the bug along the way. What I'm telling you here is none of what I'm telling you right here, this print, this pencil paper, delta debugging. I'm not telling you this so you're going to go, aha, that's how I debug. If you went into this lecture expecting me to tell you the trick to debugging, well, I got bad news. There is none. Everyone kind of has their own coping mechanism. But these are common things people talk about, and raise your hand if you've kind of more or less done one or several of the above when trying to debug. Good. You've kind of figured it out. Good job. Keep up the good work. Has anyone in here Maybe not yet. You may not have been doing this long enough to encounter this situation, but has anyone in here been working on a function? Maybe they're working on their assignment, and they're like, it's just not working. I know it, like everything seems correct, it's just not working. And maybe you're talking out loud, and the person next to you, maybe it's your mom, maybe it's your dog, maybe it's your friend, I don't know. And you say, here, look, listen, just listen to me for a second. I'm going to explain to you what's happening. And you start describing it, line at a line. You're like, okay, and then on this line it adds 7 because that's important because of X, Y, Z. And then on this line we're going to check. Oh, I see the problem. Have you ever been like vocalizing your issue only to discover that until you, like it wasn't until you vocalized your issue that you kind of saw what was wrong? I'm seeing a couple of people nod their heads. Raise your hand if that's happened to you. Yeah. What you've done is called rubber duck debugging. This isn't a joke. In fact, there's a reason the little logo of the course is a little rubber duck. It's supposed to be a rubber duck at least. Rubber duck debugging. Programmers will have little rubber ducks or other inanimate objects they will talk to. When I learned it, they called it teddy bear debugging, but I couldn't find a wiki page on that. But no, there's a real, like there's a full-on Wikipedia page for rubber duck debugging. It's remarkably effective. The whole idea is when you vocalize the logic, it necessarily slows you down. Your brain is going to move a lot faster than your mouth. So when you're saying these things out loud, it makes it easier to not assume anything. Get yourself a rubber duck that you can talk to. As silly as it sounds, this is remarkably effective. As silly as it sounds, you do it, and every time it helps you get the solution, you're going to be like, God damn it. It really was as stupid as talking at a duck. Yeah, and it works. So much so that there's a Wikipedia article, and you'll see programmers with little rubber ducks everywhere. Rubber duck debugging is fantastic. If you don't have a rubber duck, use a teddy bear. If you don't have a teddy bear, use your mom. I don't know, your grandma. Just anyone who will listen to you and pretend to care. They don't need to know anything about programming. In fact, the number of times I've gone to a buddy who is also a programmer and I've started explaining out loud, only for me to discover what the issue is, without them needing to give any input, that's usually the way it goes. Hell, half the time you come to office hours, student hours, and you ask me a question, and I say, well, you tell me what's going on. I'm just hoping that you figure it out on your own, because I sure as hell don't know what's going on. Usually if a buddy of mine asks me, here, let me explain this to you because I can't see anything wrong, I need another set of eyes. I know that really what they're asking isn't really for my input. I know they just need someone to talk to vocalize the words, the ideas, and then they usually figure it out. It's shockingly effective. Go get a rubber duck, and you'll be in great shape. Any questions about that, or any of these debugging ideas? The point of me showing you these things is not that you're going to say, okay, I'm going to go do delta debugging. No, it's not that. It's to show you that there are some somewhat well-defined strategies people talk about that you may have already been doing. And if you've been doing them, great, you're on the right track, really good. If not, take inspiration from them to come up with your own coping strategy. And yeah, I'm calling it coping strategy because that's really what it is. It's a coping strategy when you're trying to debug. Here. Now, I don't have this in the lecture notes, but if you're using like an IDE in something like PyCharm, an integrated development environment, we write our code in Colab. But as we go, and if this is like next semester and we're doing it in Java, we're not going to be using Colab anymore. We're going to be using something called IntelliJ. This is something very similar to IntelliJ, but for Python. It's an environment for writing your code, all right? And We'll just give it a second while it loads up because this computer needs a moment every time. But what's neat about these environments, and these environments, you don't need to use an environment like this in order to have access to the following, but a lot of them have what we call debuggers built in. Now, contrary to what the name suggests, is a debugger doesn't debug your code for you. It doesn't. But what it does is provides you with a suite of tools that can help you debug. So, for example, I can go and hit debug on this function here. And I'm only, oh, okay, hold on, it's taking a million years to get ready. And we'll give it a second. And I set a breakpoint right here, this little like red circle. And I'm telling this code to run. And what's going to happen is Python is going to run this program, and then it's going to get to that breakpoint and stop. It's still going to be running, but it's just paused. But what's neat about this is it gives me a snapshot of the variables. Now, it's probably a little hard to see because of the font size. But this function takes 3 parameters, right? We got parent1, parent2, and index. 2 lists and just an integer. And it's telling me, okay, well, as of now, the value of index is an integer, and it's 2. And parent1 is a list. It's 0, 1, 2, 3, 4, 5. And parent2 is a list 6, 7, 8, 9, 10, 11. And I can even say, okay, step. Do another step. Do another step. And it's showing me how the values of these things are changing for each line of code. It even gives you the ability to add, let's see, how do I do, add watch. To check things like, okay, you can even ask like Boolean expressions. You can say, oh, it's false, right? Like I can even write expressions to evaluate in real time as the code's executing line by line, which is really handy. Now, this tool is, don't get me wrong, if you downloaded a PyCharm and started implementing all your code for this course in PyCharm, great, good for you. Nothing's stopping you from doing that. And you start using the debugger and you get used to it and you love it, fantastic. Getting used to a tool like a debugger, I mean, I'm not going to teach you how to use it, but getting used to a tool like a debugger, it takes, you can watch a 5-minute YouTube video and be better at it than me. And it's a valuable skill to use. If you don't use it, though, for 161, you're not at a huge disadvantage, right? This is a pretty beefy tool, and it definitely will help you. But maybe there's an argument to be said to not use a debugger yet, to still kind of, because you're still like learning pretty early. But maybe next semester when we're using IntelliJ, which is the programming environment that has a debugger built into it, maybe you start exploring with the debug, start playing and exploring the debugger a little bit then. I'm just showing it to you now so you're aware that it exists. I'm not showing it to you now because I want everyone to start using it. I'm just letting you know that it exists. So that's pretty cool. And I'll just stop it now. Any questions about any of that? Nothing? All right. All right, file I/O. We know how to read input from a user. We know how to output information. And if you remember on assignment 1, there was a function I gave you called like load Starbucks data, right? And it loaded data from a file. And I don't remember how big that file was. There was like hundreds of entries, right? Like how many rows were in, like how many Starbucks locations were there in total in that file I gave you? 36,000. So that's a lot of data. Imagine I told you, okay, enter each one of those locations in one at a time with the input function. Yeah, exactly, you don't want to do that. Of course not, no. Instead, they were all stored in a file and we just loaded all the data from a file like that. Great. So loading and storing data in files is great. It's a great way to store information long term. Load it up when you need it. You could save it to a file for when you need it again later, whatever. Now for the Starbucks assignment, we didn't need to save anything. But we did read in the data. So how do we do that? Well, there's a couple of ways. Some of the ways that we're going to read the data, some of the ways that we go about doing it are really influenced by some pretty old standards, for lack of a better term, so just be aware of that. But whatever, I'm going to show you anyways. A text file is great if you have text data. Now, when I say text file, I don't mean like a .doc file. I mean like a basic old text file, a .txt. Now, technically, as I already kind of showed you before, the file extension doesn't really matter on any file. The file extension is just there to kind of like give people in the operating system a hint about what the file is storing. Like for example, .txt means, oh, here's a file with like text in it, right? But here, let me show you. New text file. It's called ASD. But you know what? I'm going to get rid of that .txt at the end. So this file has no file extension. But I'm going to open it with a basic text editor. Save it, close it. So there's no .txt here. I realize it's probably very difficult to see, but it's not too important. The fact is, it's just the file is called ASD. There's no file extension. It doesn't really matter. It's all about what I open it up with. So I'm going to right-click, open with, and the text editor, and yeah, there's the text there. When I add a .txt to it, it just tells like the operating system, oh, when I go to open this file is a .txt file. What type of program can read a .txt file? Well, this notepad can. So that's all. Anyways, long story short, text files, great for storing text data. Now, if I were to open like a .doc file, like a Microsoft Word file in a TXT, it's not going to work quite right. They're different. They're not the same file formats. Some basic text. There we go. I'm going to save this. And if I want to play around with this on Colab, upload. Yeah. There, it's there. And I can open it here, right? So here, I've uploaded the file, I opened it, I can even see there's the text there. Great. So now I want to load that file. So this is opening the file. Anyone? This is the name of the file right here, asd.txt. Anyone want to take a wild guess at what the second argument is in R and what it means? Just a guess. I know you probably don't know, but who wants to guess? No one's brave enough? We're opening it in read mode. It means we're going to read from the file. Is that someone else put their hand up around there? Was that what you were going to say? Pardon? Read? Okay, well, there you go. Read. Yeah, in read-only mode R. So there you go. The way this is written, this assumes the file exists in the working directory. If the file wasn't here and I said open asd.txt, Python's going to say, what the hell? Well, I don't know where the hell that is. It doesn't exist. But because it's there, it's happy. Let me put it this way. If I said open up qwe.txt, it's going to say file not found error. Where's that file? It's not there. It's right. There is no QWE. There's an ASD. It's happy. So we'll skip this here. But now there's a lot of methods in here. There's a lot. What the hell was that? Now there's all these right ones. But here, actually, let's see what happens if I print. The variable name line is there, false. It's not writable because it's a read file. It's a file that we're reading from, right? So this is a method that told us if we can write to the file or not. But we've got read. Oh, here, let's check. Is it readable? True. Yeah, all right. We have read, read line, and read lines. Now, if I do read line, and I print it out, we see this is some text, right? Why? Well, this is some text. Now, one thing you'll notice, here, watch closely. I'm going to get rid of this line for a second, and everyone pay special attention to this because this might get you. If I hit run and I say print out 44, we see 44, right? And look here. Is there anything after that 44? I'm like highlighting. Is there anything after there? No, there's nothing. But if I go back here and I say line, print out line, there is. There's like an extra line here added. Does anyone want to guess why? There's a very simple, straightforward, intuitive answer, but I'm curious if anyone can guess why.
Random guess is like whatever symbol there is to like move to the next line still on the first line.
Exactly. That's exactly what it is. Whenever you print, ignore for a moment the fact that I said print that line out. Ignore. If I go back to the 44 example, when I say print 44, the print function will display it and automatically add a new line character at the end of each one. Okay, it automatically adds a new line character. But the string that we read in, which I'm going to, come on, will this work? I'm hovering over the variable line, and look at that. The string is, this is some text /n. The line I read in already had a new line at the end. So when print added another new line, there were 2 new lines added. That's why we saw an extra gap, which was kind of neat. If you want to get rid of that stuff, there is a method you can call on a string called strip that gets rid of a bunch, like all that like extra stuff. Just FYI, it's neat. But yeah, there we go, read line. Now if I were to do it again and I call read line, we'll do it again, and let's do it again. We see this is some text, so I said read from the file, print it out, read from the file, print it out, read from the file, print it out, read from the file, print it out. Line, 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 right? Now, there's actually only 3 lines, so the last read and print out did nothing because there was nothing to read. Python just ignored it. I could have done this a million more times. It's not going to make a difference. See how low there's actually the extra lines there? You know, we created that extra new line. If I were to add the dot strip to each, it would look perhaps a little nicer. There. Now there's no extra lines. Cool. Any questions so far? Now for something that will throw off some people. I'm going to get rid of this strip as well, because whatever. Oops. Another thing that's neat about reading from a file is you can actually for loop, for in. You can use a for loop on a file, and it will read 1 line at a time. But I want you to watch carefully look at this code and make sure it makes sense. And try to notice the thing I want you to notice. When you know, you know. Here, let's change this to like the for loop. There. Why was it when I put the file in a loop, it didn't start at the top of the file? The first line of the file was, this is some text. All right? This is some text was printed out here on line 4. Let me see, before loop prints out on line 6, whatever. But when we put the file into like the for loop, it actually picked up, it skipped the first line. It started right here. You see? This is because files are like, whenever you read a line from a file, the file remembers where it is. So on line 3, I said read a line. So the file was like, okay, they read a line. If they want to read another, if they want to start reading again, they start here. You read a line? Okay. You read a line? Okay. If you were to ask me right now, can you tell the file to go back to the beginning and start reading from it? I say, no, you can't. You can't do it. If you want to, you just reopen the file, whatever. I could just, no, that's not at all what I wanted. There. If I reopen the file, it'll start over, but I can't tell a file that exists to start over. I just can't. It's tough. So this is pretty neat. When you read a file, one line at a time, it remembers what line it's on. Any questions about that? Now, my advice to you is don't read from a file one line at a time. My advice is read the whole file at once. You can read all of the data at once. And I mean, there's not a lot of text in this file, so we can see it really nicely there where it's showing me what's in there. What happens if I click view? Nope. Neat, cool. What is that? Neat. So yeah, you read it all in as a string. You store all of the contents as a string. And then if you want to do anything on individual lines in the string, well, then you just start manipulating that string. So you only need to deal with reading the file once. And an important thing to do with your files when you're done is close them. It's important to close your files when you're done working with them. Now, when you're reading from a file, it's not that big of a deal if you forget to close the file. But if you're writing to a file, it is. And we'll talk about that shortly. Any questions about reading from a file like this? My suggestion is, yeah, read all of it at once with the read method, and then manipulate the string that you read in, as opposed to reading a line at a time from the file. It's a little easier to just read it all at once and then manipulate the string than it is to work with a file. Okay, writing to a text file. So, if I want to write to a file, what do you think I should put instead of an R? What do you think I should put? A W. Well, let's give that a go and see what happens. Print my file dot is, no, writable. So now we'll check, is it writable? Yes, it is. Now, you'll notice over here, that file doesn't exist. If I'm opening a file, well, the file needs to exist. If I'm writing to a file, not necessarily. I could, my code will create a file. In fact, I think if I just do this, yeah, it exists now. Here, once I say open the file, the computer goes, okay, all right, make a new file. Python made this file on Colab there for me, which is nice. If I want to write to this file, my file dot, there's a couple of things. We've got write and write lines. And then I think there's write line? Write and write lines, yeah. But if I were to write oops, I should add a new line to the end of this. And I hit run, and I'll just reopen my file. You'll notice that I just hit run, and it's not there. I created the file, I hit run. Okay, well, it was there this time. That's interesting. I wonder what's going on here. Oops. Here. Let's hit run. Oh, try again. There's nothing there. Which is a little weird. And it's because ultimately it's because I didn't flush my buffer. But if I were to say my file.close, and I hit run, come on. There. If I close my file, then it's fine. Yeah?
Before you had the line to close the file, you also printed it for
Oh, that's because this function returns the number of characters that were written. Just because. And we can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So whenever you write, it returns the number of individual characters that were written. Just because. That's what that method does. Now, it was weird that the file didn't actually have the contents I wrote to it until after I closed it. And this is what it comes down to, that importance of closing your file. Really, it's about flushing the buffer, but I'll talk about that in one moment. If I go down here and I tell for I in range 1,000,000, and I were to say I equals j equals I, just some silly little operation, whatever, it's not really important. I hit run. Oh, it's connecting. I don't know why. Connected, okay. Oh, it ran. In fact, this loop ran 1,000,000 times in 0 seconds. There, I'll have it run, there. I told it to run 10,000,000 times and it took about 1 second to run, which is pretty impressive, right? But what's stupid is if I were to say, okay, do that 10,000,000 times, but print it out. And if I were to say, okay, print out, it takes a while. Any I/O is really slow for a computer. Anytime it needs to display something to you or write to a file, it takes a while. We are at 1, 2, 3. We're not even at 200,000 yet. I'm going to just stop it. It ran for 25 seconds and we were, what, 2.5% of the way there? Right? It's really slow. So, here's how computers work when it comes to writing to a file. Writing to a file is very slow. But what's slow about it isn't the writing of an individual value. What's slow about it is, okay, go to the file and print something. Okay, great. Go to the file again and print something. That process of going to the file is slow. Printing the thing once you're at the file is fast, but going to that file to print to it is very slow. And if I want to write 10 million lines to the file, that's going to take a while. Quite a long time, actually. So instead what we do is we have a buffer, a temporary holding place, where when I write to a file, in my Python code, when I said my file.write, those 2 lines there, I didn't write to a file. I wrote to the buffer. I could write to the buffer like that. But what will happen is every once in a while, that buffer will then go to the file and actually put the contents of the buffer into the file. So instead of going to my file 10 million times to print, I'll go to my buffer 10 million times, which is hilariously fast, and then my buffer will go to the file and write to the file only once. A lot of data, but only once. And it can print a lot of data once really fast versus printing the same amount of data 10 million times, like one thing each time, really slow. So that's the buffer. So when I didn't close my file, the buffer was never flushed. The buffer never actually went and said, okay, I need to actually write the contents to the actual file. But when I closed it, then it goes, okay, I got to close the file. Oh, but there's some stuff in the, let's just go put it in there, and there we go. So close will automatically do it. Now, there's also a .flush that will flush the buffer as well and not close the file. But at that point, whatever, not that big of a difference. But really, you close the file. For functionally, it seems to be doing the same thing, but this is a little better. Any questions about that? So we can read it from a file, we can write to a file, you can read and write to a file, you can write to an existing file, you can append to an existing file, you can start with a fresh file, you can do a lot of different things. There's a lot you can do. If I were to ask you, go read from, we'll pick up here tomorrow or whenever we have lecture next. Any last questions? Okay, remember, we don't have student hours today, but if, when you need help or anything, come to student hours, you know where to find me. All right, I'll see you all later.